Oh, yeah, sure.
Tanah airku tidak kulupakan, kan terkenal selama hidupku. Biarpun saya pergi jauh, tidak akan hilang dari kalbu. Tanahku yang ku cintai, engkau ku hargai. Tanah airku tidak kulupakan, kan terkenal selama hidupku. Biarpun saya pergi jauh, tidak akan hilang dari kalbu. Tanahku yang ku cintai, engkau ku hargai.
Yang memerah darah, yang memutih tulang, kerinduan untuk Indonesia tempatku berpulang. Sejati mengakar sejak saya lahir, semangat yang tak akan lekang hingga akhir. Indonesia hidup bernafas
Distinguished guests, participants, ladies and gentlemen,
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone.
And welcome back to day 2 of
The International Conference on Statistics and Data Science, ICSDS 2022. It is our great pleasure and honor to welcome and see all of you once again, and we hope you have been enjoying yourself at the conference so far.
Ladies and gentlemen, we would like to invite you all for a brief moment of silence to pray for the success of this conference.
Before we jump into the session, let us first deliver the summary of today's agenda.
In brief, we will have 3 plenary sessions followed by 2 parallel sessions.
Every parallel session will consist of a presentation from our invited speakers and also Q&A session, while the parallel session will be conducted with moderators in each breakout room.
We're honored to have Associate Professor Dr. Eric Fans from the University of Colorado Boulder from the USA and Dr. Kismiantini from Universitas Negeri Yogyakarta in Indonesia for plenary session 3.
We also honored to have the plenary session 4 with Associate Professor Dr. Beben Benyamin from University of South Australia, and also Dr. Anang Kurnia from IPB University, Indonesia.
And we have Doudou Fall, PhD from Université Cheikh Anta Diop from Senegal, and Associate Professor Dr. Asad Ahmad from King Abdulaziz University in Saudi Arabia, and Associate Professor Dr. Arif Sabirin from University of Leeds in the UK for plenary session 5.
As well as Dr. Bagus Sartono and Dr. Shahnas as our moderators for the plenary session today.
Now, we will have a photo session together before we officially start the conference. Now, the documentation team, you're kindly requested on screen, but while waiting for the documentation team, please, participants and speakers, make sure you have your camera on so we can take a photo as quickly as possible and get on with other agendas in this conference. Okay, so let's get ready to take a picture. 3, 2, 1. Okay. Thank you everyone for your participation. We're now going to continue our meeting to the next agenda, that is the 3rd plenary session, which will be delivered by Associate Professor Dr. Eric Fans from the University of Colorado Boulder in the USA and Dr. Kismiantini from Universitas Negeri Yogyakarta in Indonesia. This session will be moderated by Dr. Bagus Sartono. Dr. Bagus Sartono has a PhD in Applied Economics from the University of Antwerp and is currently a lecturer in the Department of Statistics and the Business School of IPB University. And Dr. Bagus Sartono has research interest in the design of experiments, statistical modeling, machine learning with a focus on interpretable machine learning, and exploratory data analysis. Dr. Bagus, you're kindly requested on screen.
Thank you very much, Azhara and Amar. Good morning, everybody. Assalamualaikum warahmatullahi wabarakatuh. Special for you, Dr. Eric. Good evening. I think it's quite late in USA currently. Ladies and gentlemen, this morning for the 3rd plenary session of ICSDS 2022, we have 2 inspiring speakers this morning. The first one is Dr. Eric Fans from University of Colorado Boulder. He graduated in statistical science for PhD program from Duke University, and currently Dr. Eric Fans is an associate professor in Department of Applied Mathematics, University of Colorado Boulder, and also the research interest is in statistical and data science. This morning, Professor Eric Fans will deliver a talk about how a statistic and data science collaboration laboratory can transform evidence into action. Later on, we will have also Dr. Kismiantini, but for your information, Dr. Eric Vance and Dr. Kismiantini, each of you will have around 30 minutes for presentation, and then after the presentation of Dr. Kismiantini for the second session, we will have question and answer session. So the first part we will give to you, Dr. Eric Vance, to give your presentation. Please, Dr. Eric Vance.
Great. Thank you, Dr. Bagus. Thank you, everybody, for attending. I will share my screen and then start my presentation. And do you see my title slide?
Yes, yes. Great.
Okay, great. So this is a 30-minute talk on how a statistics and data science collaboration laboratory can transform evidence into action. And before I start, I do want to mention that I have applied for a Fulbright Scholar Fellowship, and I am expecting to bring my family to IPB University next year. So 12 months from now, I expect to be there in person with you and to stay for between September 2023 all the way to May 2024. And just yesterday was my daughter Maya's second birthday, not her second birthday, her 2-month birthday. Yeah, so 2 months ago she was born, and so next year she'll be a year old when we come to IPB University. So this talk really has 3 parts, and the first is, why do we study statistics and data science? Why is that? How does that have anything to do with transforming evidence into action? And then, why should we learn and teach collaboration? And the second part is about how stat labs, these statistics and data science collaboration laboratories, can facilitate more collaboration between scientists and statisticians to transform evidence into action for the benefit of society. And the third part is about creating a network. So how to create an individual stat lab, and then bringing that into a global network of stat labs and potentially a network of stat labs throughout Indonesia. So the first, why do we study statistics? Why is it useful, and what really does that mean? So I believe that statistics and data science really have lots of different components, and the life cycle of statistics and data science is more complex than what each individual typically sees. So I think that this life cycle of statistics and data science starts with some understanding about the world and some question. So some expert in a field knows what they know, but they want to know more, or they want to make a decision. And so the next step really then is to collect high quality, unbiased data to answer that original question. And as data scientists, we can scrape together different data sets, determine how to collect the best data. And as statisticians, we often design experiments and studies to to answer these research questions. And statisticians can figure out better ways to collect high quality data, to reduce variation, to reduce any kind of bias, using borrowing strength from other areas. Maybe that's part of the analysis. So the typical thing maybe for a statistician is to model, analyze, and visualize the data, and then interpret those results. And then we use those results to help the domain expert who had that original problem solve that problem or make a decision and communicate these decisions to the various stakeholders. But then I don't think we're done, because sometimes at that point, we go around the circle, and then the next step is to collect more data, to ask a different research question. But if we want to transform evidence into action, then we need to take these solutions and create a plan, a data-driven plan for action. And then the final step really is to take action for the benefit of society. So statistics and data science really have different parts to play in all of this life cycle. Now, statisticians and data scientists wear many hats. We work with statistics, computing, we have to know algorithms, maybe some of us know database management, we know the mathematics, we visualize the data. Business acumen is something that's very important in the business world, understanding like what is an important question or how an answer might make sense business-wise. So to be effective, statisticians and data scientists need to know so many things: statistics, math, data acumen, programming, domain expertise, high performance computing for big data, ethics, and any one person, the one person who can do all of this is a unicorn. We call this a unicorn because this person really doesn't exist. It's a mythical figure. And no statistician or data scientist is an expert in all of the things that a statistician or data scientist really needs to know. And so because this is a mythical figure, but statisticians and data scientists are real and we do great work, I think the reason that we're able to do that, or a facilitator for being able to do great work and transform evidence to action, is to learn effective collaboration. So if a statistician has his or her core skills in statistics and math and programming, and they have a good intuition about data, and they act ethically, and if they learn how to effectively collaborate, then they can collaborate with domain experts who can bring in the domain expertise. They can collaborate with a database manager. They collaborate with somebody who is really good at high performance computing for big data. And they collaborate with people in business with the business acumen. And so the idea is that if we train our students in the core areas as well as collaboration, then they have a super skill and they can work with people who have strengths that complement their own. So my big idea really is that a collaborative statistician can enable and accelerate many research, business, and policy projects. And so if they have proper training, mentoring, and support, then they can work with researchers to enable and accelerate research, or work with policymakers, help governments make better decisions, and they can also support non-governmental organizations and work in business and industry. So for me personally, if I want to transform evidence into action, I need to collaborate with many different experts. So it starts with a policymaker or a researcher who wants to make a data-driven decision. And then typically they have already collected data, and hopefully it's of high quality and it's unbiased. And I can ask questions to understand how good of the data it is, and if anything needs to be done, maybe to counteract some of the biases in the data. But then the thing that I do most often and I think many statisticians are like this, is that we then model, analyze, and visualize that data. That's something that we are really good at. And so I collaborate with my students often on projects, and they model, analyze, visualize the data, and then they help interpret these statistical results. But then if we want to keep going down this list, we really have to collaborate with the domain experts. So they're the ones who have the problems that need to be solved, or they're the ones who need to make the decisions. And we can facilitate that. We can collaborate to help them make a decision, to help them communicate that decision in a way that maybe changes minds based on data. And the number 6 and 7 are things that we cannot do on our own as statisticians. We don't necessarily make the plan or take action. But if we don't push and help make a data-driven plan and help make that action be actionable for the benefit of society, then something that can easily happen is that our analyses just gather dust, right? They become a report and they don't lead anything to action, and they basically are a waste of time. So as a statistician, I need to collaborate, with people in all of these steps. So the point number 1 is that our students should learn collaboration. And by educating and training them and mentoring and supporting them, they can become a collaborative statistician or data scientist and help advance research and make data-driven decisions. So a question then is, how do we teach collaboration in the curriculum, in the statistics and data science curriculum? And my answer is that there are 2 places where we can teach collaboration. The first is in a capstone course. So this could be a course for the graduating students, for undergraduates, their final year, or also for master's students and PhD students. So I teach final year students as undergrads in the same class as graduate students. And this is a capstone course where the students apply all of their learning from their other courses into my course. And in that course, we work through this structure. It's called the ASCR framework. And the ASCR framework stands for attitude, structure, content, communication, and relationship. And those are 5 essential skills. And there are various skills within those 5. But these are 5 areas where I focus on training students. And when they become trained in all of these 5 areas, they do really well on real projects. So my students actually work in collaboration with domain experts from across the campus at University of Colorado Boulder and in the community and in the state. So they work sometimes with state government officials, local government officials, local businesses, and primarily researchers at the University of Colorado Boulder. So how do we teach collaboration? Well, we can teach it in a course that is based on collaboration. And for more details, in 2019, I wrote a paper in the Journal of Statistics Education, and it's available here. That paper won the Best Paper of the Year award for the Journal of Statistics Education. Now, the second place that we can teach collaboration is throughout the entire curriculum by using team-based learning. So my idea is that in some classes, especially an intro to data science class, it's really well situated to be a team-based learning class. So what team-based learning does, TBL, is it combines flipping the classroom with problem-based learning and small group learning. And so students are always working with their team to do data science. And by working with a team for the entire semester, they have to collaborate and they learn effective collaboration. And so in these classes, I don't teach collaboration skills, but the students learn them anyway, because they are every day in lecture working with their team. And then every week they do team projects. And so this is a paper that I wrote in the Journal of Statistics and Data Science Education. The journal changed its name from the Journal of Statistics Education to the Journal of Statistics and Data Science Education. And this paper also won the Best Paper of the Year award in 2021. So there have been 12 papers that have won this award, and my papers have won it twice. So moving now on to a second point is that there really should be more collaboration between scientists and statisticians and data scientists. So nearly every field uses statistics, but not every scientist should be expected to be their own statistician, right? So they have a need for statistics and data science expertise. So statisticians know many analytical methods and techniques and can create new methods when we encounter new types of data. And so when the statisticians learn to be collaborative, and if they know enough of the science or of the business, then they can enable and accelerate research projects and making data-driven decisions. So this point about encouraging collaborations between the statisticians and other researchers around campus or policymakers or businesses outside of campus, that is combined with my passion or my drive to teach collaboration. And that gets combined in a stat lab. So a question is, how do we teach our students collaboration and at the same time provide opportunities for scientists and statisticians to come together and collaborate? And the answer is here in this stat lab. So a statistics and data science collaboration laboratory, or stat lab, is an entity that can both train students in effective collaboration and provide that opportunity for researchers to come and collaborate with statisticians. So a stat lab has three missions. The first is to train statisticians and data scientists to become effective interdisciplinary collaborators who can move between theory and practice and apply all of their classroom knowledge, all of their book learning to help people solve real problems. So that's a really excellent skill for the statistician, for the students to learn. And that's the first mission of a stat lab, is to train the students to be effective collaborators. The second is to create a space for collaboration. And I call this infrastructure, to be able to transform academic evidence into real world action for the benefit of society. The third thing that a stat lab does is it teaches short courses and workshops to improve statistical skills and data skills widely. So not everybody can be their own statistician, but everybody needs more statistical skills. And so by teaching short courses, we can both help people who know some statistics to learn more, and then they can do some of their own statistics. And then other people, we can sensitize them to understand when is a good time to come ask for help. When can they do things on their own, and when should they ask for expert advice? So these stat labs can become what I call engines for development. So these stat labs, as I mentioned, if they educate and train collaborative statisticians, then and they provide infrastructure for collaboration, and they provide skills, and so they make data capable development actors. So all of these three, the collaborative statisticians, just the two, the collaborative statisticians and the domain experts, when they work together, they can create new knowledge and then transform that new knowledge into action, right? Or they can work together to make a decision that will lead to action for the benefit of society. So here is a picture of my stat lab. So I created LISA in 2008. LISA is the Laboratory for Interdisciplinary Statistical Analysis. And then I moved LISA from Virginia Tech. I created it at Virginia Tech, which is on the East Coast of the United States, and I moved it to Colorado, which is more in the center, in the mountains in the United States. And we train statisticians and data scientists to help researchers transform evidence into action. This is a photo taken in 2014, and I really like it because at this time there were 18 people in LISA. 6 of them were from North America, 6 were from Africa, and 6 were from Asia. And so we had a very, very diverse, multi-ethnic group at that time. Okay, so part of the LISA model is that we begin with education and training in interdisciplinary collaboration in a course called Statistical Collaboration. This is a required course for undergraduate students, and it's an elective for the graduate students. And the students prepare for and practice collaboration using the ASCR framework that I mentioned before. And then the students actually do statistics and data science on real projects. So typically we match pairs of students, and they meet with a domain expert and help them answer their research question or to make a data-driven policy decision. And these students work on 3 real projects over the course of a semester. And then students reflect on their collaboration projects, and experienced students can help mentor the beginning students. And this 5-step process of preparing, practicing, doing, reflecting, and mentoring is my philosophy for teaching students to become effective collaborators. And so a little bit of the outcome of the students. So I have trained 349 students and 10 postdocs, and they get great jobs and they have fulfilling careers. And so, it may be that the students are the primary beneficiaries of LISA. They work on real projects, and then when they go for job interviews, they are always asked about what they've actually done with statistics, and they can talk about any of their projects, and they always get the job that they want, and they have really good careers. But then the university benefits as well. So LISA has worked on 498 projects since 2016 at the University of Colorado Boulder. One of the things that we do at the beginning of the semester is that we have an email, and each student picks a department that they are interested in. So it could be that a student is interested in space, and they pick the aerospace engineering department. And then each student, finds the right person, finds a person in that department to send the email and share it. And so basically the email says that this is Lisa, this is what we do. If you have questions about your data, if you want some advice about how to analyze the data, come to Lisa and we can help. So as I mentioned, 488 projects. We've taught 110 short courses, and we've had 37 peer-reviewed co-authorships, 15 grants, and we've worked with 60 different departments, academic departments, and 5 non-academic departments around campus. So practically every department that there is needs statistics, and they have come into Lisa. So there are many benefits of creating and sustaining a stat lab. As I mentioned, the students are well trained, and so they get great jobs. The domain experts are able to advance their research, make data-driven decisions, and so that leads to high impact publications or better policy if you're collaborating with policymakers. Graduate students in other fields excel, so they're able to publish papers from their dissertation, graduate faster. They get great jobs and contribute to society because they don't have to spend all of their time doing all of their statistics. They can collaborate with the statistics students to help them with that part. And statistics faculty advance in their careers. They get co-authorships in high impact journals. They also have the opportunity to experience new data and develop new methods. And this all leads to increased prestige and impact for the department and for the university. Okay, now my final, just a final few slides is about the network. So I want to help build statistical analysis and data science capacity globally to transform evidence into action. And so 10 years ago, I started a network called Lisa 2020. And the idea was that we would help people create new labs and then plug them into the network, and we would grow the network. And the goal was to have at least 20 stat labs by the year 2020. So in 2020, we had 28 stat labs, and now we have 35. They are mostly in Africa, 3 in Brazil, 2 in India, and 2 in Pakistan. And I am hoping that IPB University will be able to create a stat lab and become a hub for a regional network in Indonesia and join the global network. So there is a 7-step process for creating a new lab. Step 1 is to identify a champion or an initial coordinator, a person who's really passionate about using statistics to transform evidence into action for the benefit of society, and passionate about training students in collaboration. Then that champion needs to gather support from the department and the university, and then work with somebody who's in the network to create a proposal for full membership. And then you can open up your lab, start training your students, start advertising. And so when projects come in, those are opportunities for students to be trained in collaboration. And then the stat lab submits a report, a metrics, revises the proposal, and then presents to the entire network on Zoom. And then there is a vote to become a full member. So I really do think that Indonesia has great potential to create a whole network of stat labs. And each stat lab will be training new students, training faculty and staff to become excellent collaborators. And then when they work on projects, they actually help the domain experts become more data capable, more aware of how data are useful. And so then together, they collaborate on projects that can impact hundreds, thousands, or even millions of people. So The Stat Lab creates the collaborative statisticians and the data-capable development actors. And then as in collaboration, they can enable and accelerate research, help governments make better decisions, support local NGOs, business, and industry. And some numbers for the LISA 2020 network. We started collecting the metrics in January of 2019. So in just over 2 years, in the 35 labs, they've trained over 2,400 students working on 1,400 projects. They've taught almost 400 workshops to almost 15,000 attendees and this has resulted in 146 peer-reviewed publications and a book, and that's available at bit.ly.lisa2020book. This is an index peer-reviewed book published by Taylor and Francis Chapman Hall, a reputable publisher. So the Stat Labs, they train statisticians, they work with development actors who then collaborate on projects that impact hundreds, thousands, or millions of people. And this is the second to last slide. So in the network, there's a benefit of joining this network because labs can learn from each other and share best practices. And we can have global collaborations where we can implement local solutions to global problems and then figure out even global solutions to global problems and collaborate on international high impact publications. It's a great way to keep up to date on global advances by sharing teaching resources. And we have facilitated exchanges of personnel between the labs. So members from Nigeria have traveled to Brazil, Brazilians have gone to India, Indians have gone to South Africa, and so on. And being part of this global network also increases the prestige and impact for the department and the university. So in conclusion, a stat lab can transform evidence into action by training students in collaboration. Creating this stat lab will, in fact, invite domain experts to come in with their problems, with their data, and gives us the opportunity to analyze the data to create evidence, and then the opportunity to transform that evidence into action. And then building a network of stat labs will benefit society. So thank you very much for your attention. And I look forward to Dr. Kismiantini's talk and questions after that.
Thank you very much, Dr. Eric Fans, for the very inspiring talk. Now we move to the second speaker, Dr. Kismiantini. Dr. Kismiantini is a lecturer in the University of Yogyakarta, and she got a PhD in statistics from University of Nebraska Lincoln, United States. And this achievement from Dr. Kismiantini is the first rank of lecturer in the State University of Jakarta in 2021. And then also Dr. Kismiantini got a certificate of completion for the Fulbright program. This morning, Dr. Kismiantini will give us a presentation with the title of Growth Mindset and Academic Achievements, Evidence from PISA 2018. The time is yours.
Okay, thank you, Dr. Bagus. My voice is clear enough?
Yes, yes.
Okay, thank you. Honorable Chair of International Conference on Statistics and Data Science 2022, and Dr. Eric Vance, Professor Khairil Anwar Noto Diputro, our colleagues, distinguished guests, ladies and gentlemen. First, I would like to express my gratitude to the Department of Statistics, Faculty of Mathematics and Natural Sciences, IPB University, for giving me this opportunity. It is an honor and privilege to be part of this conference. And also, I'm proud to be an alumna of this department. Okay, so let me share. Okay, so my PPT, can you see it? Hello?
Yes, Dr. Gismi.
Okay, yeah, thank you. So, yes. Okay, today I'm going to share with you about growth mindset and academic achievements, evidence from PISA 2018 Indonesia. The outline for the talk, I would like to start with fixed mindset versus growth mindset, and then PISA assessment. And PISA 2018 Indonesia, relationship between growth mindset and academic achievements, multi-level modeling, and closing remarks. All right. Okay. So let's take a look at a question about intelligence from Professor Dweck. The first is, your intelligence is something very basic about you that cannot change very much. Second, you can learn new things, but you cannot really change how intelligent you are. Third, no matter how much intelligence you have, you can always change it quite a bit. And fourth, you can always substantially change how intelligent you are. And then which mindset did you agree with more? So in this case, I would like to invite all participants to select two out of 4 questions that you are agree more, and then write it in a chat box. Okay. Please, would you like to select 2 out of 4? Okay, Dr. Eric Vance give his preference. All right. Okay, Dr. Sanas. Dr. Bagus. Okay. All right. Yeah. Okay. All right. Thank you. Thank you for participate. All right. So I saw that some of them they have mixed mindset, and then some fixed mindset, and then some in growth mindset. So if you agree more with the first and the second, you may have a fixed mindset, while for the third and fourth question will be fall into growth mindset. And if we agree with the mix between 2 2 and 3 or others combination, we may have we have the mixed mindset. Okay, thank you. So a person with a fixed mindset, she or he tends to think that the failure is the abilities, failure is the limit of my abilities. And then for the growth mindset person, she or he will think that failure is an opportunity to grow. And then another for the fixed mindset, I'm either good at it or I'm not. My abilities are changing. I don't like to be challenged. I can either do it or I cannot. And then feedback and criticism are personal. My potential is determined. When I'm frustrated, I give up and I stick to what I know. Those are thought in the fixed mindset, while in the growth mindset, I can learn to do anything I want. Challenges help me to grow. Feedback is constructive. My effort and attitude determine my abilities. I'm inspired by success of others, and I like to try new things. So, program for international student assessment, or we call it PISA. PISA measure 15 years old ability to use their reading, mathematics, science knowledge, and skills to meet real life challenges. And then since 2000, PISA has informed more than 90 countries and economics and around 3 million students worldwide. And PISA assessment focus. PISA 2000 was focused on reading, so there will be a lot of questions on reading. And then PISA 2003, PISA was focused on mathematics. 2006 was focused on science. So they cycle in every 3 years. And the 8th cycle of PISA, due to the take place, it should be in 2021, but has been postponed by 1 year because of the COVID-19 pandemic, and now take place in 2022. So some months ago, they assess some students with 15 years old. Okay, and then for today, I'm going to focus on PISA 2018, especially for Indonesia. So Indonesia has participated in PISA since 2000. Since that time, the performance in science has fluctuated, but remained flat overall, while performance in reading and mathematics has been ham-shaped. Reading performance in 2018 fell back to its 2001 level after a peak in 2009. The score was 402 on average, while mathematics performance fluctuated more in the early years of PISA, but remained relatively stable since 2009. And we see that the PISA score average in Indonesia, or for its domain below to the OECD average. And then in PISA 2018, the first time they included a growth mindset instrument. So in PISA 2018, asked students whether they agreed, strongly disagree, agree, or strongly agree with the following statement. Your intelligence is something about that you cannot change very much. So students who disagreed with this statement are considered to have a stronger growth mindset than students who agreed with it. And then according to the report from OECD 2021, students who reported having a growth mindset scored higher in PISA. And then A majority of students disagree or strongly disagree with this statement on average across OECD countries. However, at least 60% of students in the Dominican Republic, Indonesia, Kosovo, the Republic of North Macedonia, Panama, and the Philippines agreed or strongly agreed with that statement, meaning that many students belongs to the fixed mindset instead of a growth mindset. Okay, so in PISA 2018 in Indonesia, there were 397 schools were selected with 12,098 students, where they in the grade 7 up to 12. And then in the Indonesia PISA sample, so there were 8 stratum. And if we take a look, 2 provinces, there are many samples from 2 provinces, Daerah Istimewa Yogyakarta or Special Region of Yogyakarta, and then a Special Capital of Indonesia, DKI Jakarta, and then from other provinces, some school from other provinces, they put it as others. So in total, 12,098 students with 397 students. And if I do aggregate the number of students in Yogyakarta province, it was 1,868 from 58 schools. And then the sample, the number of students from DKI Jakarta province is about 1,880 from 60 school. And then for other is quite a lot, but I don't have any information or where a school come from and the school come from. I mean, I don't have any information where the province are. So from other province outside the 2 province is about 8,350, and then the number of school is 279. And if we break down the number of students on each grade, a lot of students were sampled in grade 9 and grade 10. Since in Indonesia, majority, I mean, they start to go to elementary school at 7 years old. So when they are in 15 years old, they usually in grade 9 or grade 10. So in this case, there were many students sampled in grade 9 and grade 10, and we see that at grade 7, grade 8, and grade 11 and grade 12, the number of students sampled were lower. Okay. Academic achievement. So international survey in PISA, they report student performance through plausible values. So the plausible values are a representation of the range of the abilities that a student might reasonably have. And then plausible value were first developed by Ms. Levis and Patton and Johnson based on Rubin works. In the analysis of 1983-84 National Assessment of Educational Progress, and then plausible values were used in all subsequent AP survey teams and PISA. Well, plausible values, if we know in PISA, they will give a score of 1 if the answer is correct and 0 if the answer is not correct. And then given an item response pattern X and ability theta, let Fx theta be the item response probability. And then this function could be 1, 2, or 3 PL model, for example. Then if we assume that theta comes from a normal distribution, and in this terminology, this function is the item response model and G theta is the population model, it can be shown that the postural distribution is given as followed. And then the plausible value for student with item response pattern X or random straw from this probability distributed with density. And detail about the plausible value we can read in the document of OECD. Now let's go back to the PISA score points in Indonesia versus OECD. Yeah. So from the 10 plausible values in PISA 2018, I averaged the 10 plausible values and to get to know what's going on. So yes, we know that our score in PISA were lower than OECD of average. But then the variation on each domain were about the same. And then we see as well from this box plot that there were many students that actually they have a high score than OECD average. All right, so my questions, so what is actually the number of students having equal or greater than OECD average? And then how many percentage in total? So I try to break down and then I got this. So there are many students who had the same or greater than OECD average on each domain, reading, mathematics, and science, and a lot more students got a higher score in grade 10, and grade 9. And while a few students in grade 7, a very few in grade 7, grade 8, and then a few in grade 11 and grade 12. So in total, it's about 12% for reading, and then 15% in mathematics, and 16% in science. Okay, so my question as well, whether can be possible that we take more samples in grade 9 and 10, 11 in order to increase the score and then to increase our rank in the world. All right, so and then for the growth mindset and academic achievement, as Professor Dweck developed, that the growth mindset is the belief that actually intellectual ability can be developed. And then according to the theory as well, that school that instill a growth mindset in students may boost their achievement and improve their well-being. And according to Yeager and Dweck, students with a growth mindset are more likely to be resilient, develop learning strategies to achieve complex objectives, are willing to try new learning strategies, capitalize on learning experiment, and respond positively to feedback. And then some literature were said that there are relationship with growth mindset and reading, growth mindset and mathematics, and growth mindset and science. And I have one publication in relationship between growth mindset and mathematics. So if we take a look at the relationship between growth mindset and academic achievement on each domain, we could see that here there is a positive linear trend between those variables on each domain, meaning that a student who has stronger in growth mindset, they tend to have higher in achievements. And if I take a look at those relationships among regions, yeah, we could see that students in Daerah Istimewa Yogyakarta and DKI Jakarta, they have stronger in academic achievement. Also, they have stronger in a growth mindset. And we see as well here there are positive trend between growth mindset and on each domain. And then if I take a look on the relationship between growth mindset and academic achievement on each grade, yeah, we could see here, we do have a positive linear relationship among a growth mindset on each domain. And the student at grade 10 and 11, they have higher score on each domain, and then they have a strong relationship among growth mindset and on each domain. And I'm going to discuss a little bit about multi-level modeling. So in PISA, data were collected student within school. So we require MLM data analysis to avoid the type 1 errors. And then why MLM? Because MLM recognize the existence of data hierarchies. And then in this case, I want to point out 7 major steps in multi-level analysis from Pew 2010. That the first, we should clarify the research questions, and then we choosing the appropriate parameter estimator, and then we assess whether we need the MLM or not. Then we continue to build the level 1 model and the level 2 model, and then we report about the multi-level effect size and 2 likelihood ratio model testing. So for example, in 2-level model, in this case, we allow that group student achievement within school. So there will be a residual at the student and school level. So in this case, the residual variance is partitioned into between school component and within a school component. All right, so step 1, in the clarifying the research questions. Educational researchers are often interested in research questions that focus primarily on a level 1 variable, or probably primarily on level 2, or interaction between variables. So for example, research question at the level 1, the effect of student growth mindset on student mathematics achievement, and research question that will be able in level 2, the effect of student to teacher ratio on school level mathematics achievement. And then for interaction research question, investigating whether the relationship between student growth mindset and mathematics achievement is moderated by the student to teacher ratio in a school.
Excuse me, Dr. Gismi.
Yes?
You have 5 minutes more.
Okay, so I may do more quickly. So the second step is choosing the appropriate parameter estimator, whether we select a maximum likelihood or in this case is full information maximum likelihood or restricted maximum likelihood. And then when we assess the need for MLM, well, nested data does not automatically refer multi-level modeling. So we need to take a look how much response variable variation at the present at the level 2. So we need a statistic intra-class correlation and the design effect. And Heck and Thomas and Tabata 2014 mentioned that ICC equal or greater than 0.05 and the design effect greater than 2 mentioned about the need of MLM. And then we can start with the building level 1 model. We can start with the null model without predictors. And then we can also build a level 1 fixed and then level 1 random. And then we get to build level 2 model by inserting the variable in the level 2 models. And in the multi-level modeling, we have a concern on whether we do group mean center or grand mean centered. We can do both in level 1, but for the level 2, we should do the group mean centering. Okay, and then from Pakagnela 2006, without centering with grand centering or with group centering, we should come back with the research question if we want to do interaction between those two variables in level 1 and level 2. For the level 1 predictor, we should do the group mean centering instead of the grand mean centering. Okay, and then we report the multi-level effect size reporting, whether global or local effect sizes. And then if we want to compare the reduced model, which is the model that is nested in the full model, we can do with the likelihood ratio model testing, as you know. And then I have one publication in Growth Mindset, School Contact and Mathematics Achievement, Indonesia, a multi-level model. We found that student gender, growth mindset, in the index of economic, social, and cultural status were statistically significant of predictor for student mathematics achievement, and then also girls have been reported to have higher mathematics achievement than boys in Indonesia. And as the student growth mindset increases, so do their mathematics achievement. So my concluding remark that every student can develop growth mindset, and then students who reported having a growth mindset score higher in PISA. So hopefully by instilling a growth mindset in school, we hope that they will have higher score in their achievement. All right, so thank you, Dr. Bagus, for reminding me, and I would like to return back to you.
Thank you very much, Dr. Kismi, and thank you very much also, Dr. Eric Fans, for the patience to wait until this question and answer session. Now we have the session for all participants to ask the speakers, to Dr. Eric Fans or Dr. Kismiantini. There are already 2 questions in the chat box, one for you, Dr. Eric, and one for you, Dr. Kismiantini. It's from Ibu Aswi. I think, Ibu Aswi, you want to open your mic and ask directly?
Thank you, Pak Bagus.
Okay, please.
Yes, I'd like to ask Prof. Eric regarding their experience. So, based your experience, what are the challenges for building collaborations, and how to overcome those challenges?
Great, thank you for the question. So I think there are challenges for individual collaborations, and I'll talk about that. But then there also are challenges for creating a stat lab and institutionalizing collaboration. At the individual level, I think most of the challenges occur as part of attitudes. So, Dr. Kismiantini was talking about the growth mindset attitude and how that's correlated with higher scores. Well, growth mindset attitude is one of the attitudes of collaboration. It's that as statisticians, we can learn about the domain science, we can learn more, and we can also learn more statistics. And so each collaboration is an opportunity for students and faculty staff to both learn about the domain science and to learn new methods, the appropriate methods in statistics. But so there are other attitudes about collaboration that often can get in the way. And so I think, first of all, the thing that probably is hardest for building collaborations is when the researchers think that they know all of the statistics and they don't need expert statistical advice. And I don't really talk with them much because they don't come in. I don't see them. But I think that probably is the biggest attitude is with the domain experts that they don't think that a statistician can help them. And there are ways to overcome that by teaching short courses and by being available and open for collaborations. We can probably reach out to people and help them understand that they actually could benefit by collaborating with a statistician. But then if there is somebody who realizes that they do need expertise in statistics or data science, and if they come and we collaborate, and if it's not working out very well, then probably it's about that we have not defined our roles. So we have different ideas of what our role on the project should be. Sometimes the domain expert thinks that we should just be analyzers of data, whereas we think that we know that we need to know more about the science to be able to make good analytical choices, to be able to build a correct statistical model. And so I think there are attitudes on both sides that can be a challenge for collaboration. And so a way to overcome that, I think the first thing is to just be aware of our own attitudes, be aware of what the domain experts' attitudes might be. And if we see a mismatch, then we can address it and we can try to say, we can, whatever the situation is, we can try to address that. So that's I guess my first answer of that. Does that answer your question?
Yes, thank you, Prof. Eric.
Thank you, Ibu Aswi. Also, thank you, Dr. Eric Fans. Now I will invite Mr. Sukarna. Pak Sukarna, do you want to deliver your question directly to Dr. Kismi?
Okay, no worries. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Mr. Bagus, for allowing me to directly question. The second presenters have research is very interesting for me because PISA is one of Indonesian level, I think, international level for Indonesia student score. I'm worried about the PISA level of Indonesia. That's why I asked about 3 topics. The first one about PISA itself. The second one about Indonesian student, which changed from 2013 curricula to the Merdeka Belajar curricula. And then what's your opinion about that? Which will be the best, the previous student or the next student about PISA? I think this is my question. Thank you. It's clear enough?
Yes, please, Dr. Kismi.
Okay.
Thank you very much.
Thank you, Bapak Sukarna. I would like to try to answer your questions. And well, for PISA Indonesia, PISA has been joined the PISA from the beginning. And then we have different sample sizes since 2000. And in 2018, we have more samples than before. And I do believe that if our students have more stronger include mindset, they will have higher score in achievement. And then there is evidence as well from OECD that many countries on average, they have a high score they have high growth mindset score. They have a high achievement. In Indonesia itself, based on 2018 PISA, it's about 60% of students, they were they fell into the fixed mindsets. So I think it is our job to insist our student, or to instill that they can do more. I mean, the intelligence can be developed. I believe that they will have high score in the following PISA. But then your question, curricula 2013 and curricula Merdeka Belajar, because the Merdeka Belajar is implemented in this year, right?
Yeah.
Yeah, and then the problem, PISA 2022 has been conducted probably around May, if I'm not mistaken, around May. So I believe for Merdeka Belajar curricula, we will have the result, but we may wait up until 2025 in order to have the data and then compare between curricula in 2013 and curricula Merdeka Belajar, because in 2022 I believe that the Merdeka Belajar was not implemented at the beginning year. I think they just implemented in just some months ago, right? Okay, I guess that's that I can answer, Dr. Sukarna, or probably you have another thoughts.
Yeah. Thank you for your explanation. Very nice.
Okay. So we will wait the paper of Dr. Kismantini in the next 3 years. Pak Sukarna.
Yeah.
Yeah.
Thank you. That's true. That's true, Mr. Bagus. Thank you.
Okay, thank you very much. There is Amar. Do you want to ask something, Amar, please?
Yes, am I audible?
Yeah.
Okay. Can I ask 2 questions? So I think the first question that I would like to ask is this. I find Dr. Kismetini's findings regarding the correlation between growth mindset and PISA scores interesting. But my question is, how do you isolate the effect of having a growth mindset as opposed to like the effect of other variables? I think, for example, the model is able to isolate, say, in-school variations, but what about, say, having like a better family or more incomes, or just, reverse causality, where being better in tests means that you get more appreciation, and that means that you develop a better growth mindset. How do you, what kind of research designs do you propose to find out the effect of growth mindset alone, as opposed to other variables, say that innate ability helping you to get appreciation and develop a growth mindset, or other things that might disturb the causal chain between these 2 things? I think that's my first question regarding like the possibility of other confounders, and if Dr. Eric might have like anecdotal evidence regarding introducing growth mindset in a lab, and like how that affects achievement. I think that could also like be a good addition to this point. But the second thing that I'd like to ask regarding Dr. Kismetini's findings is, I find it interesting that there's significant heterogeneity in how growth mindset is related to PISA in different grades. For example, in the 9th grade, if I saw correctly, the effect is not positive. In fact, it's like flat, and it might be negative in some grades, right? But as you go to grade 10 and grade 11, the effect is much more pronounced. It's much more positive. The same thing happens in the province level. Like I saw that in DKI Jakarta and Yogyakarta, the line is much more steep than the other provinces. So what do you think explains these kinds of differences between grades and between provinces, in how growth mindset can have different effects on like PISA scores? Thank you.
Thank you. I think I will give the first opportunity to Dr. Kismiantini to respond the question, please.
Okay, so thank you, Amal, for your interesting questions. Some of them I may be answered, and probably some of them we need still we need to think more. Yeah. And then the first one is whether we could be able to add more variables, right? So that's the point question. Yes, and it is possible. OECD published a book. It's called, is it possible I could share with you guys the book? I would like to share.
Yes, yes, please.
Okay. Okay, so this is it's called A Sky's the Limit Growth Mindset Student and School in Pisa. And there were a lot of questions that I would like to explore more, because based on those reports, yeah, especially those reports for at the international level, and we could do in the country level, let's say for Indonesia case. So they have some point out here. What does PISA show about growth mindset between different groups of students? What is the relationship between growth mindset and academic performance, the one that I talked before? And then how can growth mindset lead to better result? What is the relationship between growth mindset and students' well-being in PISA? And PISA, they have a lot of questions on well-being. And then what teacher practices can support growth mindset, what school practice are associated with growth mindset, and what policies are associated with a growth mindset ecosystem, and so on. So I think there are a lot of more that we can explore in order to understand better about those relationships. Growth mindset with other variables on academic achievement. So Ammar, you may proceed with some research on this kind of area if you are interested to get more understanding. And then the second, could you repeat? What's the point of the questions?
So there's a lot of difference between the effect of growth mindset on PISA scores in different grades, right? If I saw your slides, the line for the 9th grade is a bit flat, or in fact, it's like it might have a negative relationship. But for the 12th grade, for example, it's a more positive relationship. So there's like a difference between the effect of growth mindset on PISA performance in different grades and also in different provinces. What do you think explains that difference?
Okay, yeah. Well, you may wait our publication for this, because I started working on this on relationship. I want to see actually why Indonesia was ranked at 71 in based on the PISA 2018 results. So those my questions, and I look into about the number of students on each grade, and I found that many students were sampled in grade 9, 10, which is common, because in Indonesia they start the children start to go at elementary school at year 6, right? So when they are in 15, they are in a grade 9, right? 6, 7. Yeah, yes.
9 or 10.
Yeah, 9 or 10. So I think that makes sense why more students were sampled of in this grade. And I would like to know the relationship between growth mindset on each academic domains. Why? Because research found in OECD that a student who reported to have stronger in growth mindset, they have higher score in PISA. And I find as well in PISA 2018 Indonesia that they have a strong correlation strong relationship among growth mindset on each domain, right? And then I want to know, well, based on data, 2 provinces were selected. DIY and DKI Jakarta, and then some other provinces they put in the as others. And I show that students in DIY and Jakarta, they have higher score in PISA. And what about the grades? Because we know that there are many students were sampled in grade 9 and 10. And then from research as well, the relationship between growth mindset and reading score, we see that we have, I would say, the slope was quite strong on grade 10, 11, 9, 10, and 11. But then on grade 7, we see that they have, negative relationship. So meaning that higher grade, they have a strong in growth mindset. I do believe that. Yeah, but this is still our work, how that we contribute to instill growth mindset on the students. I think, and then from this we could to explore more, and I'm still working on it, Amar. So hopefully I will have some publication in near future year. Do I answer your question, Amar?
Yeah, I think that was a very satisfying answer. Thank you.
Okay, thank you.
Thank you. I think perhaps Dr. Eric also could think about that. Is your experience in organizing LISA, Eric, please.
Yeah, so I think it's a very interesting question about the reverse causality that, maybe, right, there's some other confounding factor that makes somebody score high and also have a growth mindset. But what I have found is that that you can teach a growth mindset, and that students who seem to have a closed mindset, they don't become as effective collaborators as those who are open to the possibility of learning collaboration. So that's one of the primary attitudes that I try to teach, is that collaboration is important and it's a skill that can be learned. And so when the students then, believe that, then they end up learning it better. And so in that way, the causality goes from teaching them growth mindset, and then that makes their performance better.
Okay. Thank you, Dr. Eric. We have one more question in the chat box from Mbak atau Ibu Vera Mayasanti. Ibu Vera, would you like to deliver directly your question? Or Vera, no? I will read it for you. Perhaps Dr. Kismi can also comment to what Miss Vera wrote on the chat box. So what Miss Vera said, that I also tried to analyze the sampling used in the PISA survey as well as the PISA publication data. We cannot get school and student data because it's confidential. Indonesian ranking on the result of the PISA survey is, in my opinion, may be due to the poor sampling method or the sample size is too small. This is my hypothesis. What do you think, Ms. Dr. Kismi, about the hypothesis of Ms. Vera?
Okay. Thank you, Ibu Vera, for your thoughts. I need to ask, meaning that you cannot get the school and student name, or because we can get the school and student data from a PISA website, we can download the data. And then I do believe that they have a good sampling method, because there are, They also publish about the design sampling, how they conduct on selecting the samples. Yeah, probably sample size we need to increase more. And in 2018, the sample size is more than the previous PISA. I guess that's, and I think it is our I would say it is our job as well to educate our children to open our mind. I mean, to grow our mind in order to develop more on achievements. I think that's my thought. Pak Dr. Bagus.
Okay, so do you think the low score of Indonesian student is not because of the sample or the sampling method, but because of it's the really competence of the students?
Yeah, because in PISA they measure about knowledge and skills. It's not the, I would say, the mathematics score itself, but it's about knowledge and skills. So much more in literacy in mathematics. I think we are lack on this, on literacy.
Okay, so thank you very much. Any question from other participants? I think we have 2 to 3 more minutes to ask to Dr. Eric Vance or Dr. Kismiantini. No? So perhaps the question for me, Dr. Eric Vance. My question is like this. In several circumstances, when we talk with the researcher from other field, I mean outside the statistics field, there is a problem when we suggest them to collect more data. For example, we suggest that you should do it with more respondents, for example, or higher or larger sample size, for example. But the problem is typically from the cost of the research. So the researchers always try to ask whether they can collect the data with the lower number of respondents, for example, but based on our statistical calculation, we need more respondents. What do you think about that?
I think that it's great if you're able to meet with the researcher before they've collected data. So that's always really, really fantastic. And if you do, and then if you're able to do a power calculation or sample size calculation, then I think it's really about explaining to them so that they understand what the problem would be to conduct an underpowered study, right? So if your power calculation says that you need 40 subjects in both the control and the treatment group, and they say, oh, but we want to do it with 15 and 15 because other people did it for 15 and 30 total, that seems fine. Then we really have to explain how, what power is and how there could be a real effect that they don't see because they don't have enough of a sample size, and how they will be wasting their time if they conduct the underpowered study. So I think, if we have that opportunity to meet with the researchers before they've collected data and we do the power calculation, then we just have to do a better job of explaining, what that means and the errors that can happen, if they continue on with their underpowered study. So that's one part of the answer. Another part is that usually researchers come to us after they've collected data, and they don't want to hear that they should go collect more data, because yes, it's always nice to have more data, but at the same time, there's always something that we can say about the data that they do have. And so I always recommend trying to help them with the data that they have, and try to answer their research question. And maybe their data is not appropriate to answer the research question, but their data could be appropriate to answer a different question. And so we can help them generate that different question, and then they answer to that question with their existing data. And then we've built up a relationship, we've built trust with them, so that next time, they come to us before they've collected their data, and we can help them with the study design, or the experimental design, and with the power calculations, sample size calculations, and help them collect the right data and the right amount of data. Did that answer your question?
Yeah, thank you very much, Dr. Eric Vance. And I think because of the time that we have, we should move to the other session of this conference. I think we will conclude this plenary sessions. Thank you very much again to Dr. Kismantini and Dr. Eric Vance, and all of you, the participants of this session. I beg the screen to the MCs, Azhara and Amar. Thank you very much. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for the absolute grateful and also awesome session from our invited speaker in third plenary session, and also thank you Dr. Bagus Hartono as our moderator. And yeah, before we jump into the next session, we would like to invite Dr. Farid Muhammad Afendi to give a token of appreciation for our esteemed speakers and also moderator from the third plenary session. For Dr. Farid, you are kindly requested on the screen.
Okay, thank you, Azhara. Dr. Eric and Dr. Kismantini, thank you very much for your talk. Very nice topic and very nice discussion also. Thank you to the participants who asked the questions. And we have kind of token for both of the presenters. We hope you like it. Dr. Eric, you look very handsome in this picture. And we are looking forward to have deep discussion next year, maybe in the near future. And this one for second presenter, Dr. Kismantini. Thank you very much for your time. Thank you. And then here we have for our moderator today. And whoa, he look younger and handsome, more handsome, I mean. Thank you, Dr. Bagus. Okay, thank you very much again to the presenters and to the moderator. MC?
Thank you, Dr. Farid. We will now continue our meeting to the next agenda, that is a parallel session in each breakout room, which will be conducted by the moderators. Presenters, please make sure you join your assigned breakout room as shared on the screen. And for other participants, you're welcome to join any breakout room that interests you. Thank you. And may you have a great parallel session.
I want to thank Dr. Bagus and the distinguished faculty and professors and everybody else who attended. And I hope to see you again in about 11 months.
We are waiting for you.
Thank you, Mr. Eric Vance. And yeah, we're waiting for you here in Bogor, Indonesia. And also we have another announcement for the participants of ICSDS 2022 that after the parallel session ends, we would like to remind you that you have to return to the main room for another plenary session, which is fourth plenary session at 10:30 a.m. West Indonesian time, GMT+7. And yeah, enjoy the parallel session and see you on the fourth plenary session.